In this video, we are going to go over statics, which means that the forces on an object are balanced, and do a couple examples from your homework. So the static situation means that an object is either at rest or it's moving with a constant velocity. Both situations are the same as far as the forces on an object are concerned. When you see the words at rest or moving with constant velocity, you immediately know that the forces on the object are balanced, meaning the rights have to be balanced by the lefts and the ups have to be balanced by the downs. Another way to say that is to say that the net force, or the sum of the forces, is zero. And we use the symbol sigma to represent net force. So that's the sigma right there. So whenever you see this kind of situation, your first step is always going to be the same. If you're not given a free body diagram, you're going to draw a free body diagram of the object. The second thing you're going to do is use that net force equation, use that free body diagram to write a net force equation in each direction. And then the last thing that you're going to do before you start trying to solve your net force equation, if you have any forces that are at an angle relative to the other forces, then you're going to resolve those into components. So let's look at a few examples from your homework. So from your static equilibrium on the first page, let's look at example C. Here you're given the free body diagram, which looks something like that. You have gravity going down, normal force going up, two different tension forces going to the right, and then friction is back and to the left. So since you have the free body diagram already done for you, your next step is to write a net force equation. In the y direction, simply subtract the ups minus the downs. So simply write normal force minus force of gravity. In the x direction, do rights minus left. So since both your tensions are going to the right, they would both be positive, and the force of friction is going to the left, so you're going to make it negative. I know the following. I know that the force of gravity on this thing is 20 newtons. I know that the tension in T1 is 10 newtons, and that the force of friction is 40 newtons. And we're asked to figure out the normal force, and then we're also asked to figure out the second tension. Or no, we're actually given the normal force. We're asked to find the force of gravity. Okay, so regardless of which of those two forces I'm solving for, I'm going to start with that net force equation. I know that the net force is zero since it's at rest, and so, real simple, the force of gravity and the normal force are equal to each other, and so we know that the force of gravity is 20 newtons. Hopefully that eventually becomes obvious just by looking at the picture. And we have 20 newtons going up, we have to have 20 newtons going down. The force of tension for the second string I could find from the x net force equation. Again, my net force is zero, so my equation will look like that. Now it's a little bit more complicated because I have three forces and not just two. So I can't just say, well, T2 is equal to 40 because there's also T1 to worry about. So kind of just rearranging that to get T2 by itself, what I would do is add the force of friction to both sides and subtract T1. Then I get that the tension in the second string is 30 newtons. You can always check yourself, make sure that T1 and T2 add back up to 40 newtons so that the rights and the lefts are the same. Again, on the first page, let's look at example F. In example F, your free body diagram looks like this. You know that the angle between that string and horizontal is 45 degrees, and you know the tension in the string is 14 newtons. Your job is to figure out what the other two forces are. We're going to start out with the same thing, write a net force equation in each direction. That T2 needs to be concluded in each direction. So I'm going to write that the net force in the y direction is T2 comma y, for the y component of T2, minus Fg. And the net force in the x equation, in the x direction, is the x component of T2 minus T1. So since I have something at an angle, I need to resolve that vector into its two components. So it might look something like this. T2x in blue, the T2y in brown. I'm going to use the cosine to find T2x, since T2x is the adjacent side. And so when you solve that for T2x, we would get 14 cosine 45 degrees, which is 9.9 newtons. Now, since this is a 45-45 right triangle, I know that the two sides should be the same, but if I didn't, then I would use the sine to figure out what Ty is. Now that I know those two components, now I can go back and look at my net force equation and just substitute those in like that for the y side and like that for the x equation. And then it's just a matter of solving that thing for what I'm given. So both cases, the net force is 0. And so Fg is the same as T2 sine 45, or 9.9. And T1 is the same as T2 cosine 45, or 9.9. That should make sense that those two components are the same, since your angle on T2 is 45 degrees. Let's look at the back at page 2 at example D. So in example D, you don't have the free body diagram, you're just given a description, and your first job is to draw the free body diagram. So you're told a 100 kilogram sled, or 1,000 Newton sled, is pulled at a constant velocity, which tells you the net force is 0, by a string that makes a 30-degree angle relative to the horizontal. And you would draw your free body diagram like this. There is a normal force, but it's not going to be the same size as the force of gravity because tension's also pulling up on it. So make sure that your normal force is smaller than your force of gravity. Write a net force equation in each direction. My y forces are the y component of that tension, the normal force, and Fg. My x forces are the x component and friction. So again, you've got an angle. Make sure you resolve it into components. So Ty would be T sine 30, Tx would be T cosine 30. Now I can't get a number for those right now because I don't know what T is. It's one of the things I'm being asked to find. So I'm just going to leave those as T sine 30 and T cosine 30 and put those into my net force equations. So both of my net forces are 0. It's moving at constant velocity. So my two equations would now look like that. My y equation, I would put T sine 30 degrees for Ty. In my x equation, I would put T cosine 30 for Tx. So solving the y equation for T, I would first add the normal force, subtract the normal force and add the force of gravity to both sides. And then I would divide by sine 30 to get T by itself. And so plugging in your numbers and then solving, you would get something like 800 newtons for that tension. Going to the x side, now that I know what T is, I can solve for the force of friction. Force of friction will be T cosine 30. We just found T to be 800 newtons, so 800 cosine 30 would be about 693 newtons. As always, if anything that I've said or done doesn't make any sense, or you still have questions, please come see me during tutorials. Remember that all the answers are on the website and the bulletin board so that you can check yourself as you're working.